Hello. Good afternoon. This is Dr. Pat. I'm going to give a recording for the first lab for General Chemistry 102. You will be using the ChemLab simulation model. And on that, as you go along, since you might have taken General Chemistry 101, I'm assuming that you have the program with you. If you go and open the program Chem module by clicking on the shortcut showing a man with a lab coat, then click on it. And then as we go along, I'll show you, click on that man. And then when you come on it, you'll see the following screen that is available to you. And I'm going to start right from the beginning so that you know, as soon as you open your screen, you will see the ChemLab simulation modules. The first experiment is gas compression. As you can see, if you highlight that, you will also see the objective of the experiment, which is to examine the relationship between volume and pressure in gases at constant temperature. So say okay, and then you will have your manual on the left-hand side under the shading of gray, and on the right-hand side, you will see a white screen, which is your lab station. Now, every lab that you open has three parts to it. First part is the introduction, second is the procedure, and third is the observation, as you can see. These drop-down menus will provide you with information as to what is to be done and how the experiment has to be followed. So now the introduction, the procedure and the introduction, please do not copy. You will have to open a Word document and write the introduction in your own words, since I'm assuming that most of you at this time will be taking the General Chemistry 102 lecture class. So this lab pertains to the first gas law lab that is there, which shows the relationship between the four parameters that can be used to describe a gas, and they are pressure, volume, temperature, and the quantity of gas. The quantity of gas, generally when we state in chemistry, is represented by the number of moles. So the number of moles is designated as mass of the gas divided by the molar mass. So it's very easy to get the moles. Now, if we keep the number of moles of gas constant and the experiment is stated to be done under constant temperature, then you have the first gas law that is there. Now, what does one understand by the word gas? Gas is a state of matter in which some particles or gas atoms or molecules are freely moving away from each other. They are, you can almost consider them as individual particles because they are very fast moving. And some of the assumptions are that when they collide with one another, it's an elastic collision and that the gases are considered as point charges. And so there is no force of attraction between the gases that is there. And the second term in the experiment is compression. Compression means you put pressure. This leads us to the question, what is pressure? And pressure we can define as the force per unit area. The units of pressure are, in chemistry, atmosphere, and the pressure, the standard unit is an atmosphere. The SI unit is Pascal, and the relationship between various other pressure units are 1 atmosphere is equal to 760 centimeters of mercury, is equal to 760 torr, is equal to 29.97 inch of mercury. 101 1,325 pascals, which is the SI unit, and 101.325 kilopascals or kPa. And then you have 14.7 psi or pounds per square inch. So these are the general information. And we know that if we compress a gas, then if the pressure increases, then the volume decreases. And that is how, in general application, when you try to fill up your flat tire, that's what happens. You increase the pressure, and so the volume decrease the pressure, and the car tire becomes flat. You put in more pressure, and the gas expands and fills up the space inside. So that is the main introduction idea, which you have to put it in your own words in order to avoid plagiarism. Next, we go to the procedure. And if you read the procedure is a repetition of, there are 2 steps involved, and the repetition of step 2 gives you all the necessary items that are required for this particular setup. What I would suggest is, or in this particular experiment, keep a control. So we see that if you go to the observation, you will see that you have to have a volume of 40, 50, 40, 30, 20. In other words, the volume is decreasing. Second thing, the volume of the syringe and other components is 4 ml. And so the total volume is a sum of the volume of the syringe you have adjusted together with the volume of the various components that make up the syringe. So let's go back to procedure. So now it says, obtain a 60 ml syringe with gauge from the gas syringe under the equipment menu. So click on the equipment menu, go down to the gas syringe, and it says a gas syringe with a gauge. So you have 60 ml syringe, so keep it there. This is your control. If you do not keep a control, then every reading that you record is wrong. And therefore, when you plot a graph in order to interpret your result, you will get it wrong. So now all you do is, because you have 5 sets of readings or 4 sets, 50, 40, 30, 20, 4. So just go to the equipment menu, or you can do this. Either go to the equipment menu, go to another, and say you want another syringe, and then you collect it, keep it, spread it aside, then, or the next thing is you copy and you paste. And as you paste, you will get your 3rd syringe, do it again, copy and paste, and you paste, you get your 4th syringe, and 1 more syringe you take out, you copy, and you paste. And then you have your 5 syringes that are there. So the first one is a control. Leave it as it is. Now the procedure says go to the next syringe and right-click your mouse. On the 2nd syringe, you right-click the mouse, and it says here, set the gas syringe volume, and you will see a dialog box that appears over here. Adjust the volume to 50, and say okay. And so now you see, as soon as the volume is decreased, the gauge pressure on the gas has increased. And repeat that. I'm going to do it 1 more time so that you can see it, because these readings, I will fill it up to draw the Excel graph and show it to you. So here, I go to the syringe, again, set the volume to 40, and then say, okay. And so now I have my observation, and you can repeat it with the remaining cylinder. Then go to the first one. They have not put in anything here. But remember, when you make your data table, make another new data table on a Word document so that the first syringe is 60 and the gauge pressure is 0. Then the gauge pressure is 0. Then the second syringe will have the air pressure, which is given already to you. And what does the air pressure represent? That's the pressure outside. So it's 98 kPa. So then go to the second syringe where the volume is 50, and you put the syringe pressure as 18. So 98 plus 18 is 116. And so you have your observation table already filling up. Then what you do is you fill it up to get your total pressure. The next one is 45 kPa. The gauge pressure is 45, and then add it up. 98 plus 45 is 143 total pressure, and go on doing it. Now, 40 plus 4 determine the total volume. So 40 plus 4 is 44. I showed you that. 30 plus 4, 30. I've not measured the 30 volume, so I'm going to leave it alone, and you can complete it. And it gives, if you forget how to do it, at the bottom it says, remember, each total volume measurement is the sum of the reading on the syringe plus an additional 4 mL, which is the volume of air in the fittings between the syringe and the pressure gauge. And so now you have your data. Now, because this is the data that you obtained from yours, it is not considered as plagiarism. Therefore, you copy the whole thing. Use your right-hand mouse. Use the right-hand mouse. Click on it to say you want to Control C. So Control C, open a Word document. Follow the template that has been provided to you. So this is experiment 1, gas compression. Do write your name and the date you perform the experiment. So your name, then experiment 1, gas compression, date. Fill up all these information, and then follow the template as it is given. Write your own introduction. Then objective. Clearly state the objective that is there. And the first, and split the objectives into small bits so that you can really, when you come to discuss your result, you will have something nice to and concrete to discuss. First, determine the pressure values for different gauge volumes. That's your first thing. Second thing that you are going to do is calculate the total pressure and the total volume. The third thing that you will be doing is convert the total volume or calculate, not convert, let's put it as calculate, because that makes it more sensible. Calculate the inverse of the inverse of the inverse of the total volume. And lastly, you're going to plot a graph of pressure, plot a graph, GRAPH, graph of total pressure versus 1 over total volume. Then obtain from the graph the linear equation and the regression factor. So these are the 5 components that you need. And then, of course, you have your materials, which in this case is air. Your equipment is the gas syringe with gauge attached to it. Gauge syringe. So the equipment is how many did you take with gauge? 5 gas syringe. So we take 5 gas syringes with gauge attached to it. Then you write your procedure down in your own words, and then remember you copied the observation, and there it is. So now you complete the calculations, get the total pressure and everything, fill it up. Next, after you fill up, remember your calculations. What are your calculations? First, total pressure. So make a table, insert a table inside this. So insert a table and you say you want observation 1, then pressure, total volume. And let's make one more. No. So let's copy this whole thing down again so that you will have insert rows above. So we have observation 1, and I'm going to just write. So yeah, I'm going to readjust everything so that I can see it. So these are your observation numbers. Then I have 1, 2, and below that I have 3. Then total pressure, total pressure, which is 90 8 plus 4 in kPa. You've got to write the units down in kPa. And so you have 60. Your total pressure is 98. The next one is 116, 116. And the third one is I got 143. Now the total volume is 60 plus 4 is 64, then 54 and 44. Now with this, I want the 1 over total volume. So calculate the reciprocal of the total volume. So if you divide, you can divide and put the numbers in. But these values, I'm going to copy them down. Now I'm going to open an Excel sheet. I'm going to open an Excel sheet so that I can show you how to draw the graph. And I'm hoping that all of you can see it. So here, I'm going to put my data, Control V. So now on the Excel sheet, it is very easy to do an invert 1 over total volume. Go to the bottom, provide the heading for the gas. And then first, let's make it like all of them have a nice background. So total volume. So under 1 over total volume. So don't forget that. And this will be in, the units will be in milliliters inverse minus 1. Now, all you have to do is put an equal sign and then 1 divided by the column beside it. And you do that. And then just to the, once the value comes, go to the tip, you will see a plus sign, drag it below, and you cover it. You will have your numbers in place. Now, what I want you to do is get the total pressure, Control X, and put it in the next column. Control V. So there you have it. Now, the X column must always be on the left-hand side, and the Y column is Y parameters on the right-hand side. So highlight the two. Then you go to, you already are in under insert. So you go to the place just above charts. There is a scatter plot. Then use the scatter plot and see how the graph looks. If you are satisfied, and I'm very satisfied because I get an extremely good graph, as you can see. And then, as you see this, I'm going to lower it down or put it beside it. Then you can see the plus sign to the right. Chart elements, go to the chart elements, put the axis chart title. And if you want the grid lines, if you don't want the grid lines, you can remove it. That's up to you. And then go to the trend line. And then the arrow will be there. So you go to the linear. Go to the linear. Click on the linear. Trend line, linear. Okay, so You click on it, then go to the trend line, hit it over there, say linear. Okay, it's not showing it over here, but then I'm going to stop the share for the time being so that we can go back, and I'm going to see if I can open my Excel sheet and I'm going to share it separately. And then I'm going to come back here, go to the trend line, linear. After linear, click on linear, go to more options, and then you said linear, and then as you come down the drop, you say display the equation on the top, display R squared, and then you say, okay, you enter, and there you see your regression equation that is there. And like I said, you can see how nice my data is, the expression. So your expression is y is equal to 6,341.7x minus 1.2197. The regression square is 0.9999, indicating that the graph is really, there is no error in this particular graph that is there. So once you get that, then you can copy this whole, highlight the graph and copy it and go back to your Word document now. Share your, where's my Word document? Word document share. And below that, you put the graph. That's your plot. So now this is the plot of pressure versus 1 over V. And so you have your regression equation. And once you finish this here, below this now, you can write down your results. So first thing is determine the pressure values for different gauge volumes. So you write over here, data provided under, okay. Now, one thing I forgot to tell you before you do your calculations, you got to go back and let me just stop the share here. I forgot to tell you that you have to need to take a picture of before you do anything. Once you copy the observations, highlight the picture of your measurements, copy, and then go back, stop the share, copy it, start the screen, the Word document. Here's the Word document, stop the share, and put your picture of the measurements recorded, so that if you make any mistake, I still have a way of assigning some grade, and each picture must show the data clearly so that I can read what you observed. And so your calculations, your observations, then your picture, and then the calculations, and below that, you can have, let's just raise it up a little bit, and then let me decrease the size of the graph, because I can always expanded when you send it to me. See, there, everything is the data provided under observations with the related pictures of the data. So we got that done. Then, so 1 is complete. 2, to calculate the total pressure and volume. So values for total pressure and volume are shown under the heading calculations. Then 3, the values for reciprocal of pressure. You may want to introduce that from your Excel sheet, include it under 1/V, and put it over there under observations. Then 3, 4, the plot of pressure versus 1/volume is shown in figure 1. And so you give a title, figure 1, plot of pressure versus 5. The linear equation relating the pressure to the inverse volume is Y is equal to 6,341.7 minus 1.22197. And the regression factor shown is 0.999, or whatever value you get. Now, this is your result. So as you will see, all the result must tally with the observation table that is there. So there are 5 points. There should be 5 terms under your result and where it is available. Once that is done, your next thing is your discussion. And now this discussion is based on the data that you have. So you see, what are the discussions you have to tell by yourself by looking at your graph, the relationship, and so on, followed by the conclusion. Many times the students ask, what is the conclusion? Conclusion is basically a single line step showing how the experiment was carried out and what were the results obtained and what was the, if you have plotted, what was the regression equation and the regression plot and the regression factor that you got. All these must be included in your discussion conclusion. So do not mix or combine result and discussion. They have to be shown as separate, because as per the grading policy, these are graded separately. So if you combine the two together, you'll get 50% of both. So make sure you write it down. So then in conclusion, what you see in this experiment, pressures at different volumes were measured. The pressures measured using a gas syringe attached to a gauge. So that's all. That's all you did. You decrease the volume and measure the pressure, and so the total pressure, the total volume and pressures were calculated, followed by the calculation of the inverse of volume. The total pressure and the inverse volume ratios was used to plot a graph shown in figure 1. This plot gave a linear equation relation between the pressure and inverse volume as, and write the equation down, with a regression factor of 0 points, whatever it is you got. Please do not copy my results and give it to me, because I will just give you a 0 for everything that you use of my values. So do it, make sure you get it and write it down. Regression value. From the regression factor and the linear equation, it can be said that for a given quantity of gas at a constant pressure, the pressure is inversely proportional to its volume. This is the statement for the Boyle's law, which is proven to be accurate. And with that, you finish it. This is how one writes their conclusion. And once the conclusion is completed, make sure everything is correctly written. I prefer you to submit it in a Roman Times format. And after you finish that, please complete the homework for the experiment. For the experiment, save every item, solve the solve, write down the homework, questions, and solve them prior to submission. Save the entire document, then upload under the specified acknowledgement Dropbox within the appropriate E-title. 。 And before you do all that, please save that on your Word document. And with that, save it. Save it. And then submit it. Stop share. And then